Hello everyone, in today's video I am going to talk about evaporation and gas pressure. Let us first discuss evaporation. Evaporation is the process in which molecules on the surface escape. It can happen at any temperature below boiling point. So the point is, how can it happen? We know that liquid molecules are having kinetic energy, and the kinetic energy of all the molecules is not the same. When molecules of high kinetic energy reach at the open surface, due to kinetic energy, the attraction force of the molecule is not able to hold them inside the surface, and these high energy molecules leave the surface. Since the molecule of less energy will only be present in the liquid, the temperature of the liquid decreases due to evaporation. Now let us see the factor those affect the evaporation. The first factor is heating. As we start heating the liquid, the energy of the molecules increases and they start moving with greater speed. Therefore, more molecules leave the liquid surface and the evaporation rate increases with heating. The other factor which affects evaporation is surface area. The number of molecules available to leave the surface will increase, and therefore evaporation will increase proportionally. So we can say that increase in surface area increases evaporation. Next factor that will affect the evaporation is air current. If the air will blow above the container, it will take away more number of molecules. So evaporation increase with increase in air current. Let's do one question based on concept we have learned. Question is, a liquid is evaporating. The liquid is not boiling. Which statement about the liquid is correct? There are few options. We have learned that evaporation takes place only at the liquid surface and the molecules with high kinetic energy only leave the surface. So option C is correct. Now let's try to understand about the gas pressure. We know that the gas molecules move freely in container and there is very less attractive force. These moving molecules keep on colliding with the container wall, so they transfer momentum to the wall. We know that the rate of change of momentum is force, so these molecules apply force on the wall. It results in gas pressure. Now let us try to understand how temperature affects the pressure. These moving molecules apply force on the wall. At higher temperature, molecules' speed increases, so they move with higher velocity and subsequently transfer more momentum to the container wall during collision. So force on the container wall increases and the pressure on the container wall also increases. So we can understand that pressure on the container wall also increases at high temperature. Let us try to do one question based on the concept we have learned. The question is, a gas is stored in a sealed container of constant volume. The temperature of the gas increases. This causes the pressure of the gas to increase. What happened to the gas molecule during this pressure increase? We have learned that as we increase the temperature, molecules start moving with high kinetic energy. So we can say that correct option to this question is option A.